Go.
Okay, so me and Walker had the problem jump, jump, jump. And the information we were given is Brooke is jumping rope in the quad at recess. Charlotte decides to collect data on the rope's path. She starts her stopwatch and observes that the rope reaches its maximum height of 2.75 meters above the ground after 1 second has elapsed. After another second, it is at its minimum of 0.25 meters above the ground. So we started with our graph by labeling the x-axis time in seconds and the y-axis height above ground in meters, because that's ultimately what we're trying to find. So we first plotted our first maximum on the graph that we got from our problem, which is after 1 second has elapsed, the height above the ground is 2.75 meters. We next plotted our minimum, which the problem gave us as well, which stated that after 2 seconds has elapsed, the rope is at 0.25 meters above the ground. From that information that we were given, we were able to come up with our third maximum, which we got that after 3 seconds had elapsed, the rope would be back at its maximum, which is 2.75 meters above the ground. After we did that and connected our points, it was easy to see what our horizontal line of symmetry would be, which is 1.5, because equally distanced between our minimum and our maximum is 1.5. And then from our horizontal line of symmetry of 1.5, we were able to get our amplitude by subtracting 2.75 from 1.5 and 1.5 from 0.25, which gave us an amplitude of 1.25 meters.
And then to finish all 5 of our points here, we found the points that the lines intersect with the horizontal line of symmetry. And so we found this by, it's going to be in between the 1 and the 2. So we got 1.5 because it's also along the line of symmetry. And then next, from between 2 and 3, we got 2.5 and then 1.5 again. And then next thing we tried to figure out was the period. So here we saw that the period as a whole was 2 seconds. So we have 2 seconds equals 2 pi over b. And then we multiplied each side by b. So we had 2 pi equals 2b equals 2 pi, divided each thing by 2, and then that comes out to being pi, b equals pi. And then after that, we can figure out our equation. So here we have f of x equals 1.25. This is our amplitude, cosine pi, which is our b, and then x minus 1 because we shift over 1 on the x-axis. And then plus 1.5 because that is our vertical shift.
Next, we found out that the next time that the graph would be at its maximum is after 5 seconds. We figured this out because, like we said before, the period is 2 seconds. So if you go another 2 seconds over to go full period to get back at your maximum, you'd have a point of 2.75, meaning that at 5 seconds it's back at its maximum of 2.75 meters. Just to reiterate, this is the equation that we found out that how to tell how far above the ground it is after a certain amount of time has elapsed. So what you would do is you would plug in your seconds for your y coordinate here, and then you'd plug it in the equation and figure out how far above the ground the rope would be after a certain amount of time has elapsed.
All right, in problem D, we were looking for after 3.25 seconds, how far the rope would be above the ground. So in final, we found out the rope after 3.25 seconds is 2.38 meters off the ground. And we found this by going on our trace graph function and putting in 3.25. We found the intersecting. So pretty much it would be putting, instead of time, it'd be putting 3.25 seconds. All right, in the last question, it was finding that Lily needed to jump in at her ideal time at 2.5 meters. So to find the two times that would be best for her to jump in, we created a line here, and then we had to find the 2 intersections, one here and one there. And after, on the calculator, and for y, putting in 2.5 and finding the intersections, we found that 1.2 and 2.8 were the times that are most ideal. So, in conclusion, the first 2 ideal times for Lily jump in when the rope is at 2.5 meters above the ground is 1.2 seconds and 2.8.